The next question in this exercise. As observed from the top of a 75-meter high lighthouse from the sea level, the angles of depressions of two ships are 30 degrees and 45 degrees. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. So let's first create a diagram. Let's draw a line to represent the sea level, and we have a lighthouse which is perpendicular to the ground, and the lighthouse has been given as 75 meters tall, and this will eventually represent the opposite side. Now there are two ships, at one at this location farther from the lighthouse, and second at this location slightly closer to the lighthouse. Let's name them as ship 1 and ship 2. This dotted line represents the line of sight of the observer. Remember, the observer is at the top of the lighthouse, and this is the line of sight. Now, the two angles of depressions have been given. So every time you lower your eyesight, the angle created at the line of sight will be your angle of depression. So for ship 1, it has been given as 30 degrees, and ship 2, it has been given as 45 degrees. Now, let us draw a perpendicular to the line of sight. This is at 90 degrees. Let us assume that the distance between the ship 1 and ship 2 is x1, and the distance of the ship 2 from the lighthouse, let it be x2. Now, why this angle is 45 degrees? Because this line of sight is parallel to the sea level. So this angle 45 will be same as this 45 degrees, alternate interior angles created by a pair of parallel lines. Now, we are going to first consider this right angle triangle. Remember, it's always advisable to consider triangle which is smaller or closer to the right angle. That should be your first reference. So now let us assume that this is your opposite, which is 75 meters for this 45-degree angle directly facing in front of it, and this is your adjacent side. So again, we are going to correlate opposite with adjacent. So we are going to use tan. Let us write a generic equation. Tan of 45 degrees is opposite over adjacent. Tan 45 from standard trigonometric tables is 1. Opposite is 75. So if you cross multiply, you're going to get x2 as 75 meters. Now, let us consider the second right angle triangle, which is the bigger one, involving ship 1. Again, from alternate interior angles, this is 30 degrees, same as this one. For this 30-degree, lighthouse is the opposite one more time. And now the adjacent side will be x1 plus x2, this comprehensive distance from the foot of the lighthouse to the ship 1. So that would be x1 plus x2. So let us write again a generic equation. Tan of 30 degrees is opposite over adjacent. Tan 30 degrees is 1 over root 3. Opposite is still 75, the height of the lighthouse. And adjacent is the complete distance, x1 plus x2. Remember, x2 we have already calculated from previous analysis. So let us replace that as 75. And now let us cross multiply that one, x1 plus times 1, this diagonal is equal to 75 times root 3. Now we can take this 75 on the opposite side, it will become negative 75. And if you want, you can take 75 common, that would be 75 in bracket root 3 minus 1. The unit will be meters, and that is the distance between ship 1 and ship 2. And that's exactly what we have been asked.